So welcome from my side as well. I'm glad to be able to hold this talk today. The topic is, as you're all aware, automating survey data harmonization, the QuestionLink R-Package. And people who have heard my previous talk quite some time ago in the Meet the Expert series will find some things familiar, and indeed the QuestionLink R-Package is basically an attempt to make the methods more convenient and easier to use for large-scale harmonization projects. And we will go through that step by step, but you do not have to have seen the previous talk in 2023, as I recall it, to understand what's going on, I hope. So, about my person, so I'm the product manager and a senior consultant in the survey methods consulting services here at GESIS. My current research interests are survey measurement, quality and comparability, and of course harmonization, that is attempts to increase comparability. The QuestionLink R-Package is the work of Matthias Roth and myself, and it was also supported by Consort SWD, which is an initiative as part of the National Research Data Infrastructure in Germany and funded by the Deutsche Forschungsgemeinschaft DFG. The general context, of course, of everything we are doing here is data integration. So let's perhaps start with the context. Why would we ever do such a thing? And specifically, data integration can mean many things in the social sciences. In general, it's bringing together different data sources to answer questions that we could not answer with only a single data source alone. And there are, of course, many research projects who combine very different kinds of data, like sensor data with survey data, social media data, and so on. My research, however, is focused on bringing together data from different surveys or measured with different survey instruments. And that alone is already very helpful for many research projects. Well, some of the reasons why we would want to bring data together is, for example, to get a larger sample size, right? Combining data across different survey programs means considerably larger sample sizes. That means we can calculate more complex models and still get robust estimates. We also have a high resolution for small subpopulations, and there is an increasing trend towards integrative meta-analysis in the social sciences, where we pool the data of different studies and analyze them together for very robust hypothesis testing and so on. It's also that we want to bring data together to close gaps in time, space, and content. We can outright synthesize time series across different survey programs. We can increase our geographical coverage by adding other international surveys, and we can add constructs that are missing from the sources that we've previously considered. And all of those things are very beneficial for a number of research questions, but they also entail quite a number of challenges. Much of my research has been focused in that context on a very specific kind of challenge, and that is, how can we make single item measures for latent constructs more comparable? So here, for example, we have a thing like political interest, and we have a single item in each case. These are single items drawn from two separate survey programs, and we immediately see that the question wording is slightly different, the number of response options and the response labels. And while I think we would all agree that both questions measure political interest, we cannot outright combine data measured with those instruments because the scores aren't directly comparable. In general, we apply a framework where we divide the challenge of establishing comparability here into three parts. The first is that we require comparable constructs. We have to check whether two questions actually measure the same construct. I've chosen an example here where that is quite obvious, but if it's not, you will have to first make sure that you're actually measuring the same construct, and the QuestionLink R-Package doesn't do that for you. The second is comparable reliability. If you want to be able to compare effect sizes very precisely, you have to ensure that both instruments have comparable reliability, or you have to at least quantify reliabilities to be able to correct your analysis. However, the focus of today's talk will be comparable measurement units, because the QuestionLink R-Package focuses solely on increasing the comparability of measurement units. And that sounds a bit strange, doesn't it? Measurement units. I mean, we are very familiar with measurement units in the context of physical quantities, such as temperature, but not so much in survey data. In temperature, it is quite obvious, for example, that a number 25 and a number 77 can actually refer to the same temperature if we consider that 25 is degrees Celsius and 77 is degrees Fahrenheit for exactly the same temperature. Behind the scenes, what's happening here is that there is a linear relationship that relates values measured in degrees Celsius to values measured in degrees Fahrenheit. And if we have access to that, in this case, linear transformation between the two units, it no longer matters what kind of unit we are faced with. And my proposition today is that we want to find roughly the same kind of thing for different response scales. And indeed, we can try to find such a relationship. It does not necessarily have to be a linear transformation, but we would not like a mathematical function that relates responses so that they can be interpreted similarly. This means that a person who would have chosen middling in one question would have chosen something like fairly interested or sometimes not very interested. This is the way to interpret this kind of relationship here. We will get into that a bit more detail soon. The issue is that unlike temperature, we cannot objectively measure it, right? We don't have direct access to what people have in their minds. So we need some strategies with which we can relate different questions to be able to infer such a mathematical transformation relationship. And the easiest approach, conceptually at least, would be the same set of respondents. If we apply measures A and B to the same set of respondents, we can directly relate what people who have, for example, chosen middling, what they would have chosen in the other instrument. So this is a very direct approach. Of course, we would ensure that A and B are presented in random order, perhaps some filler questions in between, but this is a very obvious approach. Another thing is we're dealing here with single item measures, but if we had multi-item scales with some items in common, then there are very powerful methods from psychometry that we can apply here. However, both of those options are not the use case for the QuestionLink R-Package, because I'm assuming here that it would be too costly to collect same respondent data for each instrument that you want to harmonize. And I'm also assuming that it's single items you want to harmonize, or multi-item scales that do not have items in common. So what we are left with is something I'm calling the same population link, and I will explain a bit more in a second. It's just that if you download the slides, I've added sources for those two other cases. As I said, this is not an application case for the QuestionLink package, but these sources will help you if this is closer to your use case. Now, what does it mean to have the same population, and why does that help us harmonize different measurement instruments? So our setup here is two survey programs that are randomly sampling the same population, such as the adult German population. I'm calling the surveys A and B, and I'm assuming they have different measurement instruments for example, political interest, also called A and B. Now, the key insight is, since both are random samples of the same population, we can simply assume that the latent construct, that is the true level of political interest, is distributed roughly the same way in samples A and B as it is in the population from which we've drawn the sample. Of course, I'm assuming here that the sample size is rather large, but this is usually the case for large-scale survey programs. Now, the interesting part is that the observed level of this, the actual responses to the different questions, they are not distributed the same way. At the most basic level, we might expect a different mean value for a 4-point scale or a 5-point scale, for example. And the key insight is that These are differences just in measurement, but not real construct differences. And this is, as it turns out, all that we need to harmonize two instruments. The method that QuestionLink uses in the background is called observed score equating in a random groups design, and it makes use of the setup that we just saw. The difference in observed response distributions in two random samples of the same population relates those two measurements, because we know that we have just isolated the measurement differences, and then by aligning the response distributions mathematically, we can calculate a recoding table that helps us transform one measure into the other. It doesn't matter which direction. It works in both directions. Now, I will not go into detail how this works mathematically. I've added sources here, and for some more details you can watch my previous talk on it. Just be aware that there are two algorithms that can be applied, linear equating and equipercentile equating. And the QuestionLink R-Package uses the more flexible equipercentile equating, which can also deal with skewed response distributions. Now, what would be the output of such an algorithm? So here we see on the right side the ISSB measure for political interest in 2004 and 2014. And we take that as a reference. We want to make things comparable with regard to that response scale. And once we apply the approach, observed score equating in a random groups design, actually with the QuestionLink R-Package here, we get decimal approximations of what people would have chosen in the other scale. So if we look at middling in the Albus scale in the middle here, this is most closely related to fairly interested in the ISSP scale. So we see we get some non-trivial solutions that we would not have guessed by just looking at the scales. But transforming the scale in such a manner means that we can now run analysis over the pooled data without being biased by different measurement units. The central question and also the setup for why we would need the QuestionLink R-Package is, where do we get the appropriate data? Please recall, we need random samples of the same population. But as it turns out, in countries such as Germany and many other countries, we have many survey programs that sample at least the adult population. And then we can relate measurements based on that. So here we see political interest measured by many German surveys. Each dot here is an instance where political interest has been measured in a year by a survey program. And we do see indeed that the same instrument, Albus A5 it's called that by us in the QuestionLink logic because it was first deployed in the Albus survey program, has indeed been fielded by other surveys as well. Now, the issue is that apart from that one instrument, many others exist across other survey programs. But as I said, fortunately, all of those surveys here sample the same population. So we have everything we need to apply observed score equating, right? Well, not quite. The caveat that remains, and this is the one thing that QuestionLink will help us resolve, is time. Because if you consider it, the logic that I've just described falls apart if the two samples were taken quite a bit different points in time. Think about it. If you have a sample A of the German population in terms of political interest in the 2000s, and then we have another sample in 2024, obviously we can no longer assume that this is the same distribution of political interest, right? So we cannot use it to apply observed score equating. So we would have to take care to find instances where we have the same year for surveys A and B sampling the same population, and we would not do well to do the same if there's quite a bit of time in between. So the perfect setup for harmonizing a time series of survey A and B for a certain construct would be that they have parallel time series with measurements in each year, and then we harmonize each year. This is unfortunately almost never the case. Instead, what we usually find is that we have some overlap, but only a bit, sometimes even just a single year. Now, my proposition is that we can still make use of it. This is what the QuestionLink R-Package calls a direct connection. And we can use that direct connection to relate measures A and B in 2020. We get, as a result, a recoding table, or actually two, one to recode A into B and one to recode B into A, whatever you like. Now, the thing is, we can use the same recoding table across the whole time series if we are comfortable with making one assumption, and that is that measures A and B are measurement invariant across time. But please recall, whenever you're analyzing a cross-sectional survey with a time series, we usually make that assumption in the social sciences. The problem is, of course, we cannot formally test it. But if you are willing to make that assumption, you can use the same recoding table across the whole time series if you have a single direct connection. Now, the QuestionLink R-Package also addresses the case where we almost have a direct connection, but if we are comfortable in saying that a single year difference doesn't mean a substantive change in the construct, such as political interest in Germany, then we can allow something we call time-relaxed connection, because here we relax the time constraint that it has to be the same year, and we can define how relaxed we want to be. And we can use that link to perform the equating and then harmonize the complete time series. Now, again, to the point that we had earlier where we could not harmonize A and B if there was too much time in between. Well, we are not necessarily out of luck here. Because if we have a third survey, which I call R, it will become apparent why in a second, then we can form two relay connections, A to R and R to B. And it is a benign property of equating that we can chain equatings. This means that if we have a connection of A to R and a connection of B to R, we can chain those two connections to perform a chained equating of A to B. We have thus bridged the gap in the time series of A and B by taking into account a third survey program. And such connections are not unlikely, at least for common constructs and in countries with good survey coverage, as we see here. Now note, however, that each equating is subject to a bit of random error because it depends on sampling, for example. So it would be ideal if we were able to calculate every single possible connection and every single possible equating. This would, by the power of permutation, come down to tens of thousands of connections here. And calculating tens of thousands of connections is a thing that makes a student assistants quite sad. So we've written the QuestionLink R-Package to help them and your project, of course, because the QuestionLink R-Package does all of that for you, basically for free in a matter of 30 seconds. How would you use the QuestionLink R-Package to do that? The first step is actually the most labor-intensive, but this is a step you will need to perform anyway if you want to integrate data. We need, for the QuestionLink R-Package to work, pooled data in a single data frame in the right format. Specifically, we want to bring the pooled data into a long format, where each row is a single response by a single respondent in a single survey for a specific question of that construct. Each row must at least contain the year in which the data point was collected, the question, meaning the specific instrument, and the numeric response score. But if we have that set up, then we can harmonize everything with just 4 lines of code. We start out with our prepared data frame, which I called here QLink format df. Then we pipe this or pass on to the QL prepare function, which will now look for all opportunities for equating, which we call links. We can define which kinds of links we want. We can either define to use relays or not, and we can define the amount of time relaxation we are comfortable with. Then we pass it on to the QL harmonize function, which then calculates all possible equatings for all of those connections and then summarizes all of those connections into very robust recoding tables. At this point, the harmonization solution step is complete. But we would also like to recode data, and this is the last step, QL transform. So you don't have to apply the resulting recoding tables yourself. The QuestionLink R-Package does that for you. The only argument we need here is the target, and by target I mean the question in which format all other questions should be able to be interpreted. So this is our reference question. So if it were temperature, we would define Celsius, and then all other temperatures would become interpretable in degrees Celsius, and the same logic applies here for political interest, for example. Now, this is all there is to it. But we also, for your convenience, added two helper functions. They are methods, actually, so they change the behavior of the summary and plot function if you apply it to QuestionLink objects. So if you have a QL prepare object, that is, after you have run the QL prepare step, you can call the method summary, and that will give you a text output with how many connections were found, which types of connections, how many connections per question pair. So there are maybe some questions where you have very few connections to harmonize them. And it also shows you things like the response scores per question that immediately reveals, for example, if you have forgotten to remove missing value codes and so on and so forth. So that's quite helpful, but even more helpful is the plot function. There you get the plot you see below. And this reveals immediately whether you can harmonize everything with the QuestionLink R-Package, because sometimes we don't have enough links of any type. This would become apparent by red X's marking the years, meaning we don't have any connections with that question. But if you have at least one question that has green marks, it means if you choose that as the reference question, you can harmonize all inputted question versions with the QuestionLink R-Package. So you see, it's very easy to check whether it works for you, so you don't have to find out the hard way, so to speak. Now, we're almost through. I just want to point out that what I've covered so far is just touching the surface. There are several other, we call them advanced use cases, and we've prepared a large tutorial page for those, but I'm just mentioning them so you are aware that they are there, and these are things you should consider. So the first is inverted items. That's actually quite easy. You have to recode items in such a manner that each question has the same directionality, if you like. So high values should, for example, mean a high political interest expression. That's not always the case. So you have to invert manually first. The QuestionLink R-Package doesn't do that for you, just to be safe, right? It's better to take that into your own hand based on the documentation. Now, a second thing is you will usually find survey weights in your data source. That may be design weights, like the oversampled new federal states in Germany usually, but you may also find adjustment weights that increase the representation side of a survey. And QuestionLink can deal with both of those. You just have to supply them, because remember, we leverage the random sample proportionality, the link to the source population, so we need to use the weights if they're available. We have a long discussion on missing values. There shouldn't be too many missing values, and if they are, you are in fact assuming that they are randomly missing. The QuestionLink R-Package and the underlying method doesn't work well if there's a systematic reason for missing values that depends on the construct. So if people with high levels of political interest or low levels of political interest don't like to participate in one specific survey, then this is an issue that will skew solutions, and then you have to think about that hard. We have some helper functions, as we see, to check for data integrity, and the tutorial page will explain that in greater detail of how you can use that to make sure that there aren't any data entry errors. You can also delve into the objects, that is the data objects that our functions create, because sometimes you don't want our aggregated recoding table. Recall that the QuestionLink R-Package prepares lots of equating solutions, but for each pair of questions it then condenses it down to very robust aggregated recoding solutions. But if you're not comfortable with that, you can break apart the object, look into it, and then see every one of those tens of thousands of different solutions. And then you can, for example, estimate the stability of the recoding solution, check whether it changes over time, and so on and so forth. Now, the last point is something that is very important, actually. The logic I've just shown you only works within a specific population. Because we need random samples from the same population. We cannot use that across populations, because then we can no longer assume that the distribution of the construct is the same, right? A sample from the UK and from Germany, we can't assume that political interest is distributed the same way. However, what you can do is apply the QuestionLink R-Package in each country or in each subpopulation. You need adequate opportunities for equating in each population to do so, but since that then is just a bit of data wrangling, the QuestionLink R-Package does that for you. If you supply a column that specifies the population, then the QuestionLink R-Package will create separate harmonization solutions for each population, and if you recode something, that is, apply the harmonization solution, then the QuestionLink R-Package will apply the correct recoding solution for the correct population. But again, you will need the correct, the necessary links in each population. This does not directly mean you have made the populations more comparable. But if you have in your data sources a question that you think is very comparable across different populations, such as a question from a very established international survey program where you trust that it is quite comparable and very well translated, then you can choose that as the reference, and then the QuestionLink R-Package does increase to some degree the comparability of all other sources. But you're just leveraging the pre-existing comparability of a survey program. QuestionLink doesn't increase by itself the comparability. So, basically a last slide. When is QuestionLink a good fit for you? In summary, so first of all, latent constructs, right? It's designed for latent constructs, especially single item measures for latent constructs, and multi-item measures where we don't have common items. But as a bit of a side point, you can also use it for ordinal measures for manifest quantities, such as how often do you visit the cinema, and so on and so forth. And I've added a citation below that shows how that works, at least for equating, and it's exactly the same logic, right? Second point, you would need many instruments and many data sources, because if you don't have that, if you just have 2 different survey programs and a few questions, then please just do it. Then it may be easier to do it manually, right? QuestionLink R-Package still works, but maybe it's not worth looking into it. We need at least some survey programs with some temporal overlap, as we've seen, so it can fail if the data structure isn't applicable. And lastly, as I said, comparability within populations, but not across populations, but we can leverage pre-existing comparability of well-designed survey programs. And I've added links and helpful slides here. So we have a tutorial prepared for you. We have the advanced use cases, which of course you should only read after reading the tutorial. And there's also the first link about harmonized constructs. We actually use the QuestionLink logic here at GESIS to harmonize quite a number of questions on 4 commonly used constructs. So you can already use our solutions for those and get a feel for what the QuestionLink R-Package can do for you. With that, I would like to thank you for your attention. I'm actually quite proud. It's 9 minutes, 25 seconds. I'm right on time. And I'm really looking forward to your questions.